Hi, this demo will demonstrate how to create a remote mount access deployment to the IBM Elastic Storage Server on Hortonworks Data Platform 3.0. IBM Spectrum Scale Remote Mount allows users to access files in the file system from other Spectrum Scale clusters. This gives separation of administrative responsibility and allows the storage cluster to be used for other applications and teams. The environment consists of two IBM Spectrum Scale clusters. The Hadoop cluster will establish a local scale cluster where the scale cluster will set up on all the hosts in the Hadoop cluster or at minimum on all the name nodes and data nodes in the Hadoop cluster. The ESS or IBM Spectrum Scale storage cluster also contains a scale cluster. The ESS is set up and configured by lab services. During remote mount, the ESS on any Spectrum Scale storage cluster is the owning cluster, while the Hadoop Scale cluster is the accessing cluster. The Hadoop cluster will have HDP 3.0 installed based on Hortonworks installation documentation, with deviations for IBM Spectrum Scale specific. See IBM Knowledge Center Hortonworks Data Platform 3.x for more information. A cell cluster will then be set up onto this Hadoop cluster. Once the remote mount access is configured onto the Hadoop Scale cluster, then install the Npack and add in the IBM Spectrum Scale service, which will install the HDFS transparency onto the Hadoop Scale cluster. The recommended IBM Spectrum Scale version is from 4.2.3 and up. This shows the HDP 3.0 already installed and configured. First, establish a Spectrum Scale cluster onto the Hadoop cluster, which is the HDP 3.0 cluster in this example. Set up a local Spectrum Scale repository on all the nodes. Create the gpfs.repo to point to the Spectrum Scale repo and run yum clean or yum make cache. Ensure to install the prerequisite packages required by IBM Spectrum Scale. Then install the IBM Spectrum Scale packages on all the nodes. Generate the kernel portability layer by running the build GPL on all the nodes. Now create the cluster by running the mmcr cluster command. Assign licenses for the Spectrum Scale cluster. The block size on the ESS is 16 meg. On the Hadoop Spectrum Scale cluster, there is no block size value. Therefore, for scale 500 and up, the default value is 4 meg. Set the max block size to the same value as the ESS, which is 16 meg. Now start up the cluster by running startup-a. Run getState-a to see the status of the cluster. Note, all the nodes are now in active state. Tune the scale cluster from the Hadoop cluster as the ESS client. Send the GSS client config script from the ESS to the local scale cluster. Check the script is copied over. Then execute the GSS client config script on the scale cluster on the Hadoop side with the all option. Restart scale to pick up the changes. Now create remote mount access between the two clusters. On the accessing cluster, the scale cluster on the Hadoop side, get the cluster name. Generate the authorization keys. Enable authorization. Send the key to the ESS. On the owning cluster, the ESS, get the file system name. Generate the authorization keys. Enable authorization. Send the key to the accessing cluster. Authorize the accessing cluster to mount the file system that is owned by the owning cluster. Grant the accessing cluster to mount a specific file system that is owned by the owning cluster. Go back to the accessing cluster and run the remote cluster add command to define the cluster name, content nodes, and public keys for the owning cluster. Note that passwordless SSH from the accessing cluster is required to be set up to at least one of the content node in the storage owning cluster. Identify the file system on the owning cluster are to be accessed by nodes in the accessing cluster by running the remote fs add command. On the accessing cluster, mount the file system on all the nodes by running mount -a. Check the mount point using mmls mount -l or run mount on all the scale nodes. Now that the remote mount is set up between the two clusters, verify that you can access the parser file system. The ESS has some files on the root directory. Go to the mount point that is accessible by the accessing cluster. Note there are some files in this cluster already. Go to the accessing cluster and note that the same files are seen. Create a file on the accessing cluster. Check that the file is created on the ESS. Remove the created file. Check that the file is gone from the ESS. Now we're ready to do the Impact and Scale service deployment. Log into the Nambari GUI. Stop all the services. Ensure that the stop operation is complete. Install the Impact on the Nambari server node. Create a directory to place the Impact package in. For example, /root gpfs_Nambari. Uninstall the Impact package. List of uninstalled packages. Note this directory contains information for install and uninstall of Spectrum Scale service. Ensure to keep the files in this directory as is. Run the Spectrum Scale bin installer. Ensure that you know the input value before running the installer script. Accept the license. Use the default port. Enter the Nambari server IP address. Use the default Nambari server username and enter the password. Wait for the installation to complete. After this installation is complete, specific directory files are now modified for HDFS transparency. Therefore, next step is to deploy the IBM Spectrum Scale service. Ensure the Spectrum Scale cluster are active and mounted. To not capture the shared mount point into services which require local directories, one can unmount the GPOS mount point on the Nambari server by running the unmount command. Otherwise, need to check each service's directory during deployment to ensure the mount point is not used. Log back into the Nambari server. Do Add Service. Select the Spectrum Scale service. Ensure the GPFS master is on the same node as the Nambari server. In the Sign Slave and Clients, Ensure all the nodes are set to GPFS nodes. Under the Customize services, ensure that the GPFS environment standard and advanced fields are correct. For remote mount, the cluster information should be already filled in. Check the cluster name, quorum nodes, storage type, file system name, and the mount point. This is an optional field. This will create the local cache disk for Hadoop usage if the Hadoop local cache field is filled in with the name of the disk stanza file. Go to the Advanced tab. Under the GPFS Ambari server environment, add an Ambari password and the GPFS repo URL. The GPFS repo should be the same as what is set up in the Hadoop cluster. There should be only one HDFS transparency RPM added into the GPFS repo. Proceed. After reviewing the content, deploy the service. If there's errors during the install process, fix their errors and retry again. Once the deployment is completed, review the summary information and complete the installation. Spectrum Scale is now integrated. Start all the services. Wait until the start all operation completes. Once the deployment is complete, the Ambari Spectrum Scale service will operate only on the local scale cluster on the Hadoop cluster. The ESS or storage cluster is not managed by the Spectrum Scale service. On the Hadoop scale cluster, check the data replica minus all value from the mmlsfs command. On the Ambari GUI, change the DFS replication to match the data replica minus all value through the HDFS service configs panel. Search for DFS replication. Change the value from 3 to 1. Save the configuration. Restart all the required services. Wait for the operation to complete. Can disable the checkpoint alert because HDFS transparency does not do checkpointing because HDFS transparency is stateless. Verify the cluster by running service checks and ensure that you can read and write to the ESS. Run your test workloads. Thank you for viewing this video on how to deploy Spectrum Scale with remote mount access on HDP 3.0.